Hello everyone, you're welcome to today's class. And today we're going to be considering a topic titled Dimensions of Physical Quantities. So I stated here, in physics, the word dimensions has a special meaning. It usually denotes the physical nature of quantities. So in dimensional analysis, we have the symbols that are used to specify length, mass, and time are L. Now, this bracket here signifies the dimension. This bracket signifying dimension. So I have L representing length, M, that's capital M, representing mass, and capital T representing time, respectively. Now, for example, if I'm looking for dimension of velocity, if I want to get a dimension of velocity, which is given as v, now I know velocity v is equal to displacement over time. So displacement is a measurement of length. So because it's a measurement of length, I'm going to represent, I'm going to replace, instead of displacement, I'm going to put capital L, which I'll have it as capital L, then divide by my time is denoted using capital T. So I'll have it to be L T raised to the power of minus 1. So this is the dimensional analysis of velocity. Then the next one is if I'm looking for dimension of acceleration. Now for me to get a dimension of acceleration, now which is given denoted with A, my acceleration is equal to velocity over time. Now, my dimension of velocity is given as Lt raised to the power of minus 1. Then my dimension of acceleration is going to be dimension of velocity, which is Lt minus 1 over time. So here I already have Lt minus 1 over dimension of time. So the same thing as me having Lt minus 1, that's dimension of velocity, now multiplied by this 1 over the dimension of time. So it becomes dimension of t raised to the power of minus 1 down, because I have it as 1 over the dimension of time. So I have that. So if I multiply it, I'm going to have, according to law of indices, I'm going to have it as Lt raised to the power of minus 2. Because according to law of indices, t raised to the power of minus 1, I have t raised to the power of minus 1. I'm going to add them. So I'll have t raised to the power of minus 1 plus t raised to the power of minus 1, which is going to give me Lt raised to the power of minus 2. That's for acceleration. Then the next one, if I'm looking for dimension of volume, I'll come, first of all, I have my volume is length times breadth times height. Now, all these are all measurement of length. They're all measurement of length, both the length, the breadth, and the height. Now, so I'm going to have it as L multiplied by L multiplied by L. So I'll have it to be equal to L raised to the power of 3. So this is the dimension of volume. Like that, same to the others. Now, example. I want to solve an example under dimensional analysis. Example. Deduce the dimensions of A, force, B, pressure, C, work. C, I have work. Now they say I should deduce the dimensions of the following. Now, for me to get the first one, which is A, I'm going to say my dimension of force is equal to, now the formula for finding force is mass times acceleration. So now it's equal to dimension of mass times dimension of acceleration. Now, so my dimension of mass is given as capital M, then multiplied by my dimension of acceleration is given as LT raised power of minus 2. So now my dimension of force becomes MLT raised power of minus 2. So that's my dimension of force. So the next one, B, I'm looking for dimension of pressure. Now the dimension of pressure is equal to dimension of force over dimension of area. So now my dimension of force is being given as MLT minus 2. That's my dimension of force that I got previously. My dimension of force is given as MLT raised power of minus 2. Then my dimension of area, since area is measurement of length, that's length times breadth, I'm going to have L times L, which is L squared. So multiplied by my dimension of area, L squared. So I'm going to have it to be MLT minus 2 multiplied by L minus 2, because it's inverse. So 1 over, according to law of indices, 1 over L raised power 2 is same thing as L raised power of minus 2. So according to law of indices, here is same thing as L raised power of 1. So 1 plus minus 2 is same thing as 1 minus 2. So I'm going to have it to be equal to ML minus 1 T minus 2. So this is the dimension of pressure. Now I move to the last one, which is the dimension of work according to the question. Dimension of work. Now, so for my work, that's C, my dimension of work is equal to dimension of force times dimension of distance. So dimension of force times dimension of distance is going to give me my dimension of work. So my dimension of force is MLT minus 2. Then my dimension of distance is L. So if I multiply this, L times L is same thing as L squared. So I'm going to have it as ML squared T raised power of minus 2. So that's my dimension for work. So I have it as ML squared T raised power minus 2. So thank you very much. I hope you all enjoyed today's class. So see you in the next class.